All right, guys, are there any questions on any of the assignments thus far?
No, sir.
Questions on any of the assignments so far? Brendan, hood down. Guys, heads up, let's focus in. Need a note sheet. Tyler, head up. You have note sheet.
He has a note sheet.
Are there any questions on any of the assignments so far?
Anyone else need a note sheet? No response.
All right, guys, so up to this point, and what we're starting today is solving. We're going to start solving these higher degree polynomial functions. Now, the different ways, there's been four kind of main ways that we've solved polynomial functions. And one of the first ones that we dealt with is factoring, because we did this with quadratics, and factoring still works with these higher degree polynomial functions. The second method that we have is to graph. Because graphing does work for these here. Because our second method is graphing, so we can solve them by factoring, we can solve them by graphing. The third method that we have for solving these is using the quadratic formula. And the last way that we have is completing the square. So we have factoring, graphing, quadratic formula, and completing the square. These are the four main ways that we do have to solve quadratics as well as higher degree polynomial functions.
Okay. Since I have like 4 free different classes, or like on my bathroom pass, can you use one of those?
You'd have to ask Denny. Any questions on this so far? So, when we look at this here, this first one here, we're solving these because all the ones that we'll be looking at today is solving. So when we look at this here, 2x cubed minus 12x squared plus 18x equals 0. And we're going to solve this first one by factoring. And when we solve any of these by factoring, the first thing we need to look for is the greatest common factor between these three terms here. Is there something in common with all three terms? 2. Anything else with 2x? If we can factor 2x out of every single term. And if we factor 2x out of each of these terms, it's going to make it a little bit easier to solve it, a little bit easier to work with.
I have a question.
Yes?
At the cube and the square.
We cannot because they have different powers. Guys, wake up. Head up. No. So if we factor 2x out of 2x cubed, well, the 2 factors out completely. And if we remove 1x from x cubed, we're left with x squared. Minus. If we factor 2x out of negative 12x squared, it'd be 6x. Plus, then we factor 2x out of 18x, which gives us 9. It's 9. Because the 18 divided by 2 would be 9. And when we divide the x from x, it just becomes 1. So we have 9 times 1, or just 9.
Oh, wait, so it doesn't have an x?
Because we factored out completely, it's removed. Any questions on this so far? Okay?
Since it has a 0.
No. We're not dividing. Now at this point here, we have two things multiplied together that equal 0. Whenever we multiply 2 or more things together to equal 0, one of them must be what? 0. So we're either saying 2x is 0 or x squared minus 6x plus 9 is 0.
If you do 2 times x squared, aren't you just getting 2? Wait, so you have to do 2x times 6x, right?
Which would give us 12x squared. If you multiplied it back out, we would multiply each one of those by 2x to get back to this here.
So why'd you write it like that? Like, do you have to do it like that?
Yes, because we need to find the greatest common factor first. Because here, this is not factorable as it was to begin with. But if we pull that greatest common factor out, we have 2x times x squared minus 6x plus 9. Well, we can solve 2x equals 0. Because here we can divide both sides by 2, telling us x is equal to 0. That is one of the solutions. So one of the solutions for this polynomial is 0. Now we need to look at the other one. So we have x squared minus 6x plus 9. This is a quadratic. Because we've worked with these all last chapter, because we can either solve this by factoring, graphing, completing the square or quadratic formula. Now this one here we can factor. We can use our 2 sets of parentheses with 3 spaces. Because if we look at this here, 2 sets of parentheses with 3 spaces, we don't have a greatest common factor, mainly because we already pulled it out as 2x. Now we look at the signs first, and we look at the signs, we'll look at the sign of the third term. If the sign of the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. So here the third term is positive, so the signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. Now we need to find the factors of the first and third term. So what multiplied together gives us x squared and x, because we only have one set of factors for x squared. Now 9 has a few different factors, because we have 1 and 9 or 3 and 3. So which one of these two do we want to try first? 3 and 3. Now we can check this here off to the side. We can say x times negative 3 is negative 3x. Negative 3 times x is, and negative 3x minus 3x is. And the middle term that we wanted was negative 6x. We didn't multiply the x and x because it still would give us x squared. We got x and x from the factors of x squared. We didn't do 3 and 3 because 3 times 3 is 9. That's where we got them from. So these are the correct factors. Any questions on this so far? We have 2 things multiplied together to equal 0, so one of them must be 0. So we're either saying that x minus 3 is 0, or x minus 3 is 0. Now we just need to solve for the value of x. Yes, sir?
Okay. Are you done with it? Never mind.
So here we can add 3 to both sides, telling us x is equal to 3. And with the other one, we would add 3 to both sides, telling us x is equal to. So our solutions for this are 0, 3, and 3.
Okay. So, you're going to college right now, right?
I finished.
Oh, you finished? Can you show us some of your math after your class? Yeah, I kind of want to see that.
A lot of what we did is some of this here, but not too much other than that. It depends on the class. Yes. Determining prices of oil as it changes per year to estimate the overall cost that it would go out. Anything that deals with a rise or lower, any case or form, we would take points and go about it that way. You can also say with the overall amount of grain that your cattle eats across any amount of months, it's not going to be consistent, it's not going to be constant. So if it's going up, down, curving, we can estimate it by these higher degree polynomial functions to estimate how much you would need in the future. All of this is based on these equations and using them to estimate out. Here we're finding specific values where they're 0. Those we would use to estimate overall values going forward. Any questions on any of these here so far? So the next one we're looking at is this here, 5x to the third minus 40x squared plus 80x is equal to 0. So we'll do one more of these by factoring. Is there a greatest common factor between these three terms? 5x. So we can factor it out. We can pull 5x out of all three terms. And if we pull a 5x out of 5x cubed, we're left with x squared minus 40 divided by 5 is 8. And if we factor an x out of x squared, we're left with x plus 80 divided by 5 is 16. And if we factor the only x out, we're left with just 16. So we have 5x times x squared minus 8x plus 16. And again, we have two things multiplied together to equal 0, so one of them must be 0. So we're saying that either 5x is equal to 0 or x squared minus 8x plus 16 is 0. So 5x equals 0. Well, to solve this here, we can divide both sides by 5, which tells us x is equal to 0. Now again, for the other one here, x squared minus 8x plus 16 equals 0, so we can solve it by factoring, graphing, completing the square quadratic formula. Any of these will work. So if we wanted to, we could graph this. So we could say x squared minus 16x plus, wait, no, because this was, make sure I get this right, minus 8x plus 16, so minus 8x plus 16. Let's try this one more time. Plus 16. And we can hit graph. Because again, when we graph these, we're trying to see where it crosses the x-axis. Yeah, that would just be 4 and 4. And we see where it crosses the x-axis. We can go second graph to look it up more particular. And we see what value of x makes the y value 0 is at 4. So the solution for this here is x is equal to 4. Now we went over this with quadratics and graphing. If it crosses the x-axis, or it touches the x-axis but doesn't cross it, it has an even multiplicity, even number of zeros there. So there's 2 of them. Now if we'd factored this, we would have gotten the 2 factors of x minus 4 and x minus 4. Because the third term, 16, is positive, the signs are the same, and they match the sign of the middle term, which is negative. So we'd have negative and negative. The factors of x squared that we want are x and x. Those are the only factors. And out of all the factors of 16, we're going to have 4 and 4. And because we have two things multiplied together to equal 0, one of these must be 0. So for the first one here, we can add 4 to both sides. Well, these will cancel, telling us x is equal to 4. We can do it with the other one. Add 4 to both sides, telling us x is equal to 4. So we do still get 3 solutions, 0, 4, and 4. Any questions on any of these here? So let's look at the next one here. So we want to find all the zeros. We want to find the zeros of this here, negative 2x to the fourth plus 16x squared minus 32. Then sketch the graph of the function. For the homework, I'm not going to make you sketch any of the graphs, but let's go on and start there. Let's start with the graph for this here. So in the graphing calculator, if we're solving these here, we can graph them. We can plug them in. So we have negative 2x to the fourth plus 16x squared minus 32. If I type that in correctly. Negative 2 plus 16 minus 32. So we've all been able to type that in. And then what do we need to do next? We need to hit graph, and we're trying to see where it crosses the x-axis. What value of x makes the y value 0? We don't care too much about what the y value is when x is 0, unless it's also 0. But if we go second table, where are the two spots where the y value is 0? Negative 2 and 2, yes? Now at negative 2 and 2, did it cross the x-axis? No. Now for this one here, we are going to have 4 zeros. But it actually works out the other two zeros are 2 and negative 2. So these here are our two solutions. Actually, it is all the solutions, because both of these have a multiplicity of 2. They work twice. Now, I can verify or I can show you that this is true with this here. Because again, when we did synthetic division, if it's a solution, if it's a factor, the remainder was what? 0. So what we can do is we can do synthetic division here. And again, if we don't have all the solutions, this is what we're going to go to. And as we go further into this, we're going to graph it. And especially on the ACT, if they give you higher degree polynomial functions and tell you to solve, find the zeros, find the solutions, graph it first. Because if any of those solutions are natural numbers, for we can cross the x-axis, find them easily, go that way first. And if it doesn't give us all of them, then we can go to synthetic division to try to find the rest. Now going across the top, we would have negative 2 for x to the fourth. We would have 0 for x cubed, 16 for x squared, 0 for x, and negative 32. And we'd bring the first negative 2 down. Now 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. 2 times negative 4 is negative 8. We add straight down. 16 plus negative 8 is 8. 2 times 8 is 16. 0 plus 16 is 16. And we do 2 times 16, which is, and negative 32 plus 32 is, well, we knew that already because we knew that negative, or 2 was a solution, yes? Now, because it crossed the x-axis, it didn't actually cross the x-axis, it just touched it, it should have a multiplicity, an even multiplicity. Now, instead of rewriting this back out and doing it again, is I could set up another synthetic division. So right below that, I could rewrite negative 2, negative 4, 8, 16, and reset it back up. Or I can add a little cubby hole here, drop the negative 2, and do it again. 2 times negative 2 is negative 4. Negative 4 plus negative 4 is negative 8. 2 times negative 8 is negative 16. 8 plus negative 16 is negative 8. And 2 times negative 8 is, and 16 plus negative 16 is. So 2 not only worked once, it worked twice. If we did this again, we would get a remainder different than 0. Now, I wouldn't write this down if you are following along with this here, because if I did 2 a third time, 2 times negative 2 is negative 4. Negative 4 plus negative 8 is negative 12. 2 times negative 12 is negative 24, which gives us negative 32. Because however many number of 2's work, we could keep doing and getting 0 for each one that worked. But here, we can see it only worked twice. Now, the degree we started with was 4, yes? So if we did the synthetic division once, it brought it down to degree 3. We did it a second time, now it's a degree 2, so it's a quadratic. So we do have one more here, negative 2, because that was another value that worked, yes? So if we do this, it's going to take it from a degree 2 to a degree 1. Linear, those are the easiest ones to solve. Negative 2 times negative 2 is 4. Negative 8 plus 4 is? Negative 2 times negative 4 is positive 8, which gives us 0. If we get it down to degree 1, let's just put the variables back in and solve. Because if I put the variables back into this here, well, this is the remainder. This is our term without x. This is our term with x. So really it's telling us that we have negative 2x minus 4 is equal to 0. Well, if I wanted to solve this here, we would add 4 to both sides, telling us negative 2x is equal to 4. Divide by negative 2, telling us x is equal to negative 2. Aren't those all the values that we had? 2, 2, negative 2, negative 2. We have all 4. So this here did help us. We already had them. But this here, this method is helpful, especially if we don't find every solution. Or it does give us a certain number, 5 solutions on the graph, but 2 of them don't show up on the table. We can use this here to find the other 2. Because the biggest thing with any of this here is if we aren't given all the solutions by the graph, we need to get it down to a degree 2. Because at a degree 2, we can use the quadratic formula. Plug A, B, and C in and simplify. Or get it down to a linear and solve it from there. But our biggest goal, if we're not given all the solutions by the graph, we need it down to a degree 2. So let's look at this next one here. X to the 4th minus 18x squared plus 81. So in the graphing calculator, we can say x to the 4th minus 18x squared plus 81 is what we're given. And then what will we need to do? We'll hit. So we do see that it intersects the x-axis in 2 spots, yes? And goes back up. It doesn't cross them. And to see exactly what those values are, well, they are negative 3 and 3. So the solution for this here is x is equal to negative 3 comma 3. We do actually have 2 more values, which are going to be negative 3 and 3. Because anytime it touches the x-axis but doesn't cross it, it's considered to have what we call an even multiplicity. There's an even number of zeros there. Any questions on this here? Any questions on anything we've done so far? So we have this next one here. 4x to the 4th minus 40x squared plus 36 is equal to 0. So what's the first thing we can do with this here? We can put it in the calculator. We can graph this. We can say y equals, clear, 4x to the 4th minus 40x squared plus 36. And we can hit graph. How many times does it cross the x-axis? So how many solutions do we have? So our 4 solutions are what? Yeah, so -3, and we do have 3. -1 and +1, yes? So x is equal to 3, -3, 1, and -1. We could simplify it to ±3 and ±1 since we have the positive and negative case of the number, so we can rewrite it as this here. Any questions on any of this here? Now there is something interesting with this here. Is there a number, a greatest common factor number that goes into all 3 of these here? All 3 of these terms. Is there a number that divides into all 3? 4, yes? What I want to show you is this here. If we divide everything by 4, well, this is just going to be x to the 4th, yes? -40 divided by 4 is -10x squared. And 36 divided by 4 is 9. We can divide a number out. It's not going to change anything. It will change how the overall function looks. Because if we plug this in, I'll plug it one lower, because we have x to the 4th minus 10x squared plus 9. Because this is our new function, yes? Now it will change a good number of points. There's 4 points it won't change if we graph it. It doesn't change where it crosses the x-axis, where this is 0. Because if we look at the overall points, so we're -4, the y values are different. We're -2, the y values are different. At 0, they are. At 2, all the other numbers, but at our solutions, 3, -3, 1, and -1, the y value is still 0. So dividing out that constant term, as long as it's not a variable, we can do it, and it won't change it. It won't change the function. Questions on any of this here? This is the last one we'll look at today. Now, whenever we have a power greater than 1, we have to get it equal to 0 for solving. If we have a power greater than 1, we need this equal to 0 to solve. So the first thing we can do here is what? We can subtract 14x cubed from both sides. And if we subtract 14x cubed from both sides, we get 2x to the 5th minus 14x to the 3rd plus 24x is equal to 0. Anybody have a guess at what one of the values of x is going to be? 0. Why would you guess 0? Right, if we look at this here, is there a number listed here that doesn't have a variable? Is there a number listed up there that doesn't have a variable? Well, the 0, yes, but every other one has a variable with it. So if I plug 0 in 2x to the 5th, well, 0 to the 5th is still 0 times 2 is 0. 14 times 0 to the 3rd, well, 0 to the 3rd is still 0 times -14 is 0. 24x, 24 times 0 is. So really, any of these here, if we do not have a constant term, we know one of the values is going to be. Interestingly enough, whichever variable has the smallest exponent will tell us how many zeros we actually have, how many solutions of 0 we have. So here the smallest exponent is 1. So we have 1, 0. If it had been x squared instead of just x, 24x squared, we would have had 2 zeros. 2 zeros at 0. Now we can graph this. So I'll clear both of these out. So we'll have 2x to the 5th minus 14x to the 3rd plus 24x. Now this here is, we're expecting to have 5 solutions. We're expecting to have 5 numbers that will work. And we'll get more into that, exactly how we know that, with 4 0.6, our next section. But if we look at this here, we see that it does cross the graph at 5 locations because there's 5 spots it crosses. And one of them we already knew, which is 0. Now, if we go second table, I see 3 values where y is 0. Yes? We see one at -2, we see one at 2, and one of them is at, but how many times did it cross? 5. So this here is one of the first ones that we really have to do the synthetic division. Because if I divide those 3 solutions out, I'm going to take it from a degree 5 down to a degree 2. So what we would need to do with this here is our synthetic division. Now we know x is 0. X is, because it was 2 and -2. These are our 3 solutions so far. We need 5. So the number of solutions that we need, especially from the graph that we want to get, truly, we wanted to get 5. Because if we got 5 nice solutions, we have every solution, so we're done. But at worst, for this here, we need 2 less than the degree. So since the degree is 5, we needed at least 3. We've got 3. Now we can pick any one of these 3 to use first. We can use 0. We've not used 0 before, but we can still use 0. Now across the top we'll have 2 for x to the 5th, but we don't have an x to the 4th, so it's going to be 0. We do have an x to the 3rd, which would be -14. We don't have an x squared, so it is 0. We do have an x term, which is 24, and our constant term, which we don't have, is 0. Now, hopefully this is the easiest synthetic division we've done, because here we'll do our first one. 0 times 2 is 0 plus 0 is 0. 0 times 0 is 0. -14 plus 0 is -14. 0 times -14 is 0. 0 plus 0 is 0. 0 times 0 is 0. 24 plus 0 is 24. And then we do 0 times 24, which is 0, and 0 plus 0 is 0. Since we have a remainder of 0, it is a solution. Well, we already knew that. Now, it crossed at 0, so we can't use it again, but we could use 2. And do this again, because now we went from a degree of 5 down to a degree of 4. Once we do this with 2, we'll go from a degree of 4 to a degree of 3. So now we'll do 2 times 2, which is 4. 0 plus 4 is 4. 2 times 4 is 8. -14 plus 8 is -6. 2 times -6 is -12. 0 plus -12 is, and lastly, 2 times -12 is, and 0 plus -24 is 0. So we've done this with 2 of our solutions. So we only have one other one left, which is -2. And once we do this with -2, we're going to take it from a cubic down to a quadratic, and we can solve from there. Now, -2 times 2 is -4. 4 plus -4 is -2 times 0 is -6 plus 0 is -2 times -6 is, and -12 plus 12 is. Now, we've done this synthetic division with 0, 2, and -2. Do we have any other solutions left? But what's the degree of our following polynomial? 2. We could plug it back in and see, because this 0 here is the remainder. The term next to it, the -6, is our constant term, the term without a variable. The 0 next to it is the term with x, and the 2 is the term with x squared. So what we're left with is 2x squared minus 6 is equal to 0. Questions on how we got to this here? will 2x squared minus 6 factor? Well, if it factored, it would have been a nice number on the graph, or a fraction. Now, we could do this by completing the quadratic formula, but there was one other. We had the square root method. But the square root method had the one particularity that it had to be set up as a set of parentheses squared, or we couldn't have a middle term. Do we have a middle term? So we get x squared by itself. So the first thing we can do is add 6 to both sides, which tells us that 2x squared is equal to 6. Divide both sides by 2. Yes. And if we square root both sides, the square root of x squared is x is equal to. Anytime we square root both sides, we had to add the plus or minus. It'd be the square root of. So that's how many solutions? 2. How many were we looking for? So the solutions are plus and minus 3, 0, 2, and. So we're going to continue on with this tomorrow. But again, this is solving these, because if we can find at least 3 solutions with graphing, or the degree minus 2 solutions by graphing, we can find the rest with the quadratic formula.